We got all the terms for today's lesson on here, and then I'll try to remember to put little arrows on the ends of these. So I've got two lines. And then if I draw something that cuts through, that's an example of a transversal. So I am not going to expect you to write a definition for me on this kind of stuff ever. But no, it doesn't have to be vertical. You can take that and rotate it any direction you want. So if my drawing on my paper was like this and I took a line and drew it through the other two, the line that cuts the other two is the transversal. Yeah, so maybe I'll write in parentheses here. Cut two lines.
Does it work if the two lines are parallel?
You bet it works if they're parallel. Can it go through three lines? Yes, but generally we say if it cuts two lines, then it's a transversal. It's not like it has a special name or anything that goes through three. And I don't know where we go through three very often. So that's in a real general sense. And then what I'd like you to do is I'd like you to number all of the angles with a little number, just like this. So I'm going to go 1, 2, 3, 4, and I'm going to do it counterclockwise, and then I'm going to go to this other intersection and go 5, 6, 7, 8. I'm going to go counterclockwise. Can you see? Well? Awesome. So from this drawing here, when we have these two lines that are cut, the angles that are on the outside are said to be external or exterior. Did I write external? Exterior. And then interior, that makes better sense. So they're exterior, they're on the outside of the two lines. So I think with this drawing here, I'm just going to list under here 1, 4, 6, and 7. Exterior, and then I'm using the angle symbol. Those are exterior angles. I'm sorry? Yeah, so this is the angle symbol with a letter S. So plural, angles. Yeah, you can write the word if you wish. I'd rather write the symbols. So what do you think 2, 3, 5, and 8 are?
Interior.
Yeah, interior. It makes sense? 2, 3, 5, 8 are interior. Okay, then 1 and 5. You see how 1 and 5 are on the same side of the transversal? So they're on the same side and they're kind of in the same position. They're both on the upside of that line. So 1 and 5, they correspond to each other. And 4 and 8 correspond to each other. And even though they're not the same measure, they still correspond. And they correspond in their location. Whereas they're on the same side of the transversal, and they're on the same side of their relative line. So 2 and 6 correspond, and 3 and 7 correspond. So those are corresponding pairs. So I'm going to write that. 1.
But one's interior and one's exterior.
Yeah, you're right. One is inside, one is outside. So the exterior, the interior is not a part of this definition of what a corresponding angle is. So 1 and 5, 2 and 6, 4 and 8, 3 and 7. Corresponding angles. Goes inside. But you're right, you said they're not parallel lines. So that means there's no relationship between them. There's nothing special about them. They're just corresponding. They are on the same side of the transversal. So they're either on the left side or the right side of the transversal I drew. And they are on the same side of each of their relative lines. So number 1 is above this line, number 5 is above the other line. Both 1 and 5 are on the left side of the transversal. And that makes them corresponding. But it'll make more sense to you when we do this with parallel lines. So do you have a ruler? So you can just do both sides of the ruler and you can make 2 lines that are parallel to one another? Yes? Okay. So I'm going to try that like this. But I'm going to move mine down a little. And then recall if you put an extra arrow on each line, that says that they're parallel to each other. So this time I'm going to call it line L and line M. Yep, they can parallel. Make yours pretty good size. Because we're going to do a bunch of labeling in here. So now I made my transversal in blue, changing colors for this. So let's number things the same. 1, 2, 3, 4, 5, 6, 7, 8. Use the same pattern that you used on your first pair of lines with the transversal. That way, everything that you wrote with exterior angles and interior angles and the corresponding angles, it's the same in both of our drawings. So we don't have to write anything in black again because you have that real close by, right? So now 1 and 5 are corresponding angles. You have a protractor? Measure them up quick. How do they relate to one another? The lines are parallel, as you're saying. Does that check out when you measure them?
Oh, if you had perfectly parallel lines.
If you have perfectly parallel lines, yeah.
Which it says on the parallel.
So when we have a transversal cutting parallel lines, corresponding angles are the same. They're equal. So if you were to take that line L and just slide it and keep it parallel, eventually it's going to sit right on top of line M. Therefore, 2 and 6 are the same. 3 and 7 will be the same. All the corresponding pairs have the same measure. Okay, so let's do this. Measure angle 1. And what the measure of angle 1 is. And write it like this, lowercase m, the angle symbol, number 1 equals. Come up with your measurement to the nearest degree. Oh, I'm sorry, let's do it in this one here, excuse me. Yeah, so we're done with this, like we're done with it for good. So for the most part, we're gonna work with parallel lines from now on out. So the measure of angle 1 over here. So most of yours should be different, right? What should it be, Ellen? Thank you, Rylan. Okay, so based upon that, and what you know already, how are you going to find the measure of angle 4? It's a linear pair. Linear pair are add up to 180. They're supplementary. So if you have room in your drawing, you probably do. You're working in pencil, yes? So if my angle 1 is 120, then angle 4 is going to be, mine will be 60 because 120 and 60 add up to 180. And go through and label as many of the angle measures as you can. Are you all progressing? Anybody not? Make sense? Easier than fractions and decimals with single digits?
Yes.
Yeah, but we haven't done anything with this. We're just doing facts right now. Okay. All right, let's look back at these again. What did you find about 1 and 3? Same measure. How about 5 and 7? 6 and 8? Okay. Do you know what that relationship is called? Those are vertical angles. We've done this already, right? Yeah, so 5 and 7 are a vertical pair. 1 and 5 are what? Corresponding. 4 and 8 are corresponding. Corresponding angles, when a transversal cuts parallel lines, are the same, yes. Vertical angles are always equal to each other. Look at this, same side. So, I mean, you guys, you're good readers. That's one thing I will give you in Haines, is we have really good reading. Same side, interior. Same side of the transversal, interior. What's the relationship there? They're not corresponding. They add up to 180. Okay, same side exterior. So the same side of the transversal, but they're exterior, like 1 and 6. What do they add up to? 180 also. So you can use these facts to come up with unknown measures. And in construction, this kind of stuff gets done all day long, continuously. In mapping, it gets done all the time. In orienteering, it gets done all the time. Now, we need alternate exterior angles. We got to do that. So alternating or same side, that refers to the transversal. So if we alternate on either side of the transversal, and the angles are exterior, they would be like 1 and 7. So you alternate on either side of the transversal, and then you pick exterior angles. So exterior's out here, alternating is opposite side. So 1 and 7 is an alternate exterior pair. What's the relationship between their measures? They're the same, because if you slide everything together, they're like vertical angles.
Why wouldn't 1 and 8 be alternate exterior?
1 and what?
8.
1 and 8.
Is 8 interior?
8's interior, 1 is exterior. So we can't say that they're interior or exterior.
Okay, what about 1 and 4?
1 and 4 is a linear pair.
They can't be a linear pair, one alternate exterior.
No, because if they are alternate and exterior, they're exterior to the parallel lines, and they alternate across the transversal.
Yeah.
So this word here, or same side, this refers to the transversal. And then the interior and the exterior, that refers to the two lines.
But that 4 is an exterior.
4 is an exterior,
Yeah.
1 is an exterior.
But it's on the same line as 1, so it can't be the same measurement. Because the line equals 180?
Yeah, but who says it has to be?
Hold on, back up.
Oh, I thought that's what you were asking. They can be
Ask,
the same.
ask again, maybe I don't understand your question.
Why wouldn't 1 and 4 be alternate exterior angles if they're both exterior and they're on opposite sides of the transversal?
Okay, so why would 1 and 4 not be alternate exterior? They are alternate, yes, I'll give that. But they are both exterior to the same line. By this definition, they have to be exterior to both of the lines. If you want, we can go that deep. It's there. I mean, I'm taking stuff that's way, way more complex, and we're trying to make it more simple and straightforward. I'll send you with a book if you want. It's another one.
And I think too, what he's just giving you is what angles equal the same, so that when you look at it, you can know the angle measurements
Yeah.
right away.
So,
He's not getting into the definition of what that means.
That's not what the definition states.
the definition does state that alternate exterior angles have the same measure.
Who's other teacher's favorite?
Well, show me where then, okay? Show me the definition. And show me that the definition doesn't say that.
I'm not saying I know the definition, I'm saying that's not what it says in the name.
It's not what it says in the what? In the name?
Yeah.
Well, by the way, this word is used in geometry. By the way, this word is used in geometry. It is referring to being exterior to both of the lines. So we have to have, if it's a pair, between the pair of angles, they have to be located on the outside of one and the outside of the other line, which are being transversed by the transversal. Yeah, I don't want to spend any more time with it. I'd be happy to talk about it further and show you more with the definition. But in middle school, we don't give you the hardcore definitions because they're beyond our reading level to begin with. But they exist. And what I'm trying to do is put it into more simple terms. This is how this works. So let's see. If we use this symbol here with that particular, no, I'm sorry, I'm jumping ahead. Alternate interior. So two things, alternate both sides of the transversal, and then both angles need to be inside of these two lines. So we can have alternate interior over here, like 2 and 8, but when the lines are parallel, what's true about the measures of alternate interior angles? They're going to be the same measure. So alternate exterior are the same, alternate interior are the same measure, corresponding are the same measure. Okay, then using this symbol here, we could write that L, then the symbol in M, and it gets read line L is parallel. I'm sorry, line L is parallel to line M. So there, those are your facts and definitions. This is your work. It looks big, it looks long, but I think once you get going, it's going to go pretty fast. Where are you at? For number 1? Yeah, so 1 and 3, what can you conclude about them? Can you conclude anything about their measures? They're both exterior. Are they or not? 1 and 3? Okay, so they're both exterior, and then where are they located? Compared to the transversal, where are they located?
On the left.
They're exterior.
I almost said pre-image.
So it says that they like each other on that,
Okay, if and only if the lines are parallel,
1 and 3.
do we have the equal measure relationship?
Yes.
Yeah, but on the paper it says like M1 equals M measure 3.
But it doesn't.
And then what are we supposed to say about?
Okay, well, good, you're reading it. So they're alternate, I'm sorry, they're same side exterior angles, right? Okay, and if they are equal to each other in measure, what can you conclude?
M and N are parallel. M and N
Can you explain why that is true, Dalton?
Because if they're the same angle, then, I don't.
It is the same. It is the same.
So in this worksheet, they're saying that 1 is equal to 3.
But they're not, they don't look the same. No, you flip them.
Okay, but they're saying they are, even though the image doesn't appear that way.
Well, you listen to the following for that.
Okay, so in this case here, even though the image doesn't look like they are the same, we are moving away from that concrete to abstract, and we're saying, there's the image. It may or may not be correct, but what is true is that the measure of 1 equals the measure of 3. If that is true, then what has to be true about this image? Why is that, Hayden?
No, it doesn't tell you it's parallel, but you have to assume that. Like they're not all the way parallel.
Oh, yeah, they do have to be parallel.
Yeah.
They would have to be parallel. They're not the same.
Why is there a cross through the equal sign on
Oh.
question?
If they're not the same, they're not parallel.
Oh, it
If
shows-
they're not parallel, that's the only way they can be
The
the same.
only way they can get exactly there.
That actually doesn't make sense.
No, it has to be.
The line has to be
It
parallel.
has to be parallel.
This line goes both ways.
Okay, hold on. This is what I want.
This is what you
This is what I
want.
want.
You want us to
Yeah.
It's discussion.
So we are out, unfortunately, in 2 minutes. But Hayden, would everyone listen to what Hayden says? Because Hayden has an answer that he believes is correct, and he has an argument for why he believes it's correct. Can you share that again? Okay, go for it.
actually sure if it's correct, but.
It is correct.
Okay. It must be parallel because it's like the only way the entire equation works.
If the lines aren't parallel, then the angle, since they're both exterior, can't be the same unless they're parallel. Because
Okay, hold on a second. We're gonna continue with this, but I'd like to stop where we are a little bit. And Rylan, I can see you're on a roll and you're running with that, and Emma, you are too, that's great. And TJ? But
Just say what you
what I'd like to say is, I want to try to promote discussion within you as a group with some of these ideas and these ways of learning which are different. And one way that we can do that is by making sure that we give who is speaking a chance to be heard by all. And then all to have a chance to speak. And I'd like to come back to this tomorrow. So, here's what I would suggest you do. I'd like you to go through question number 10 to the best of your ability. But then when we come back tomorrow, we're gonna go over, and you guys are gonna explain to one another why you believe your answers are correct in number 10.
Just question number.
Just up to number 10, that's all. Up to and including number 10. Okay.
There's no exact answer for all of mine. Why did I get this?
Imagine going out to buy.
Joel told me that you said she wasn't done with something.
She isn't, but we don't have 7th period today.
Okay, well, it'd be nice if she'd come in and finish it so I can give this stuff back to them tomorrow. I don't know when, how that can get done.
Okay, yeah, she said